Hi, I'm Adrian Hall. I'm a developer advocate for AWS Mobile, so I talk to mobile developers all the time. And this is about a new service that we launched in reInvent last year in November called AWS AppSync. So just a quick history of why we're doing this. Data access protocols have been around forever. They're really, from the mid-1960s was the first client-server protocols were developed, and remote procedure calls, RPCs, were actually invented. Over time, they've changed. The most biggest change to this was in probably 2000, when REST was introduced to the world. In 2007, the iPhone was introduced. 2008, Android was introduced. And around that same time, a lot of the web applications also became much more API driven. And that led to a change in the way that we think about protocols. Instead of them being server-to-server communications and bulk transfers, they're now very much tied to the UI that you develop. And so Facebook, as the primary instigator here, although there were a couple of other efforts, introduced GraphQL as an alternate. Now, why a new protocol? Here are the three competing standards, if you like. SOAP was really the heyday of XML, and it really required the client and server to understand each other. It's a problem. And it's a problem because your client always has to match your server. You don't get any versioning, you don't get backwards compatibility, things like that. So your client and server have to match. And REST was really a reason to change that, where REST is all about resources. So think files, think database tables, that sort of thing. REST is about accessing those. And they did away with that client-server protocol. They said, you know, the clients can just take what they want, the servers can give what they want, and everyone will be happy in the end. Well, that led to lots and lots of data being transferred, which in a UI-driven world is not really a good idea. So GraphQL has been really brought forward. It's a JSON standard. We've got the client-server protocol back. We've got that contract back, but we can discover it, so we don't have to link the two together anymore. Why not just continue using REST? After all, it was a perfectly good protocol for a number of years. Well, the first thing is it's chatty. If I'm developing a standard data-driven app, master detail type records, where the master is a list of records and the detail is the content of one record, and you'll see that pattern over and over and over again in data-driven apps. What I would need to do is I'd need to do one REST call for the list of items, but all I get back is the IDs of the items. I don't get the actual data. And then I have to go and do, for every single record that's in that list, I have to do another record, another transfer. So that means that if I'm displaying, let's say, 20 records in my list, I have to do 21 requests round trip. Okay, so that's chatty. Too much information. When I go and request those 20 records, I'm likely to going to be getting the entire record back. Now, that means that if I only want the title, let's say I'm doing a movie database, okay? I'm doing IMDb. I can scroll through the list of movies, great. I can search movies, wonderful. And then I go and click on a movie, I get a whole bunch of information, okay? Now, if I did that on REST, it would work. I mean, there's nothing wrong with it. But if I only wanted to display the title, I have to grab all that information about the movie, extract the title, and throw the rest away. Tooling. REST has one, maybe two tools. It's called Postman in general. That's what everyone uses. And you have to know about the other end. It's a generic tool. It's a generic HTTP query tool. There is no discovery in REST. You have to know what's on the other end. Real-time and offline, REST, you don't get those. They're just not a problem. What's that mean for the actual experience of the user? Well, it bumps up the delay between Doing a UI action like clicking on a button, clicking on an item in the list, loading the list in the first place. One of those UI actions, the delay between initiating that action and displaying the result is rather high. Now, if you've got a responsive app, you only have 0.1 seconds to respond to events. That's how long the brain says it will take for you to process. If you get to 300 milliseconds, 500 milliseconds, just a half a second, it will feel sluggish. You'll know it. It'll be, this app is slow. It's slow to respond. It's laggy. Those are some of the terms that you hear. And as soon as you get up to a second, you're switching off. You're going and doing something else. A second doesn't sound like a long time, but it's an eternity when you talk about apps. So how can we get that time down? And just one last note about this. The average round trip from your app to a data center in the cloud and back again is 200 milliseconds. Okay? So if you're relying purely on the network to respond to data, you're already going to feel sluggish. Doesn't matter what you do. Doesn't matter how quick your code is on the other end, your app is going to be sluggish. So, data-driven apps. The data requirements, how many people here have more than one mobile device? Tablet, mobile device, web browser on a PC or a Mac, phone, watch? Anyone have a watch? No? A couple of you? The data requirements for each of those form factors is different because the UI is different. What I can see on my phone, my smartwatch here, is different to what I can see on the phone, and that's different from the tablet, and that's different from the web browser on my PC. That's a natural evolution of data and the data density that you can put on the screen. Okay? Instant access to data. Everyone wants it. Everyone wants to be told when data arrives. I'm pretty sure this is fairly common. I have not been able to get on Wi-Fi today. Anyone else experience that today? Yeah, it's a common problem in conferences. It exacerbates the problem. We can't rely on our network. And yet we still want our apps to continue working. So we have to deal with this. Even if you're in an area which has perfect Wi-Fi coverage, okay, campus of a major corporation, for example, as you go from building to building, cell to cell, you'll go off Wi-Fi onto a wireless network and then back onto Wi-Fi again, okay? And finally, scale. Scale is an issue. I haven't talked to a mobile developer yet that has told me anything less than their ambitions of 1 million users for their app. It seems to be the benchmark. Well, how do you pay for 1 million users? How do you develop for 1 million users? Because those are architectural concerns that you need to deal with. So GraphQL, I mentioned that earlier. It's a query language for APIs. It's a query language for the UI. It's specifically designed for developers who are front-end developers who want to develop data protocols that are driven by the UI. Okay? The resources are defined in a schema. Schema has types, and it has operations, queries, mutations, subscriptions. Okay? The queries and the server orchestrates the data. So that means that your data is insulated from the client. Or rather, the client is insulated from the data. And the client does not care what format the data is in. All it sees is types. Okay? You can do it over multiple transports. The most popular is a HTTP post through a secure connection. That's what we support. If you're doing some of the real-time operations that we'll get into, you'll be doing WebSocket connections, permanent WebSocket connections with an MQTT subsystem for subscriptions. It's efficient. The client can ask for the data that they want, and we'll see that in a moment. And it's self-documenting. Part of the GraphQL spec is to say, for the server to say, these are the operations that I can perform. And that allows a vast quantity of tooling that's built into IDEs. That's we'll see a tool later on that allows you to test the capabilities. There is one endpoint / GraphQL, some host / GraphQL. Really easy. Never have to worry about multiple endpoints ever again. And this is a common problem with REST, is because we deal with multiple data sets, we inevitably explode the number of HTTP endpoints that we write. All of those HTTP endpoints have different code paths, different data sets, different requirements, and that takes a lot of getting used to. So one endpoint, one code path, all of the business logic in one place. So at this point, when I'm doing these one-on-one conversation with developers, they say, well, should I use REST at all? For the right purpose. If you are accessing files, or you are accessing videos, or photos, or things like that, resources, then yes, use REST. It's the right job for the protocol for the job. If you're doing UI and you're doing structured data in response to UI events, then use GraphQL. Pick the appropriate protocol for the use case. There's still a use case, by the way, for HTTP endpoints. I'm not saying if you don't want to use REST or GraphQL, you happen to be just trigger an event that kicks off some background process, and then I don't worry about the return path. Use just a HTTP endpoint. You don't need to do something fancy. So I'm going to switch to my web browser now. And show off, there we go, show off GraphQL queries. So this is a tool called GraphQL Playground. It's one of the tools that I have. And I have a small movie database. Now, I mentioned introspection. This is a standard tool. So this doesn't know anything about my data source, but it can actually discover through the GraphQL protocol of all the queries I've got. And if I look at, for example, this is a movie database. If I look at all movies, I can see what parameters I can use, and I can see what it returns in terms of a type. So if I want a list of all the movies, I can just go all movies. Now, one of the unique things about the GraphQL protocol is I have to tell it what I want to return. I only return the data that I need to use. So I have to tell it what that is. So ID, self-descriptive, okay, and title. And this would be, for example, I'm doing a list of movies and I'm displaying the title and I want to click on one to show more information. So let's run that and we'll see what we get back. What we get back is JSON. Everyone here can the guys at the back read the left-hand side there? It's a list of movies, but you can notice I've asked for give me all the movies with the ID and title, and I've got a list of all the movies. This all movies comes from all movies here, and it's just got the ID and title. Now, what happens if I wanted to do that paging exercise? Well, I can go over to my schema again, and I can see all movies has got a skip and an after, a first and last. So I could say, give me the first two movies. Let's just try that. And you can see now I've only got two. I can do order by, movie order by. And the order by is here. And I can do, let's see, by release date. So I can go order by and release date ascending. So that just gives me a sort criteria. And again, I've got two different ones. So, and then if I wanted the next two, I could say, okay, now I've got the two and I'm doing the second page, so I'm going to do skip two. And it'll give me the second two, but again, in release date order. So these are all the capabilities. Then there's other operations. So I might click on a movie, and I can see I've got, let's see, under all movies, I can see I can get all movies ordered by that. Where's the movie? Movie. And I need an ID. So I can take this one here, and I can say I want a movie which is an ID of that, and that will just give me the same thing with just the title, but I can now say, and I want the release date, I want the created at, I want the slug. In other words, I want the detailed information, and I can now get that. So this would be clicking on a single movie gets that information. So that's a really quick introduction to the GraphQL process. Can we switch back to the slides, please? Can we switch back to the slides, please? Thank you. So, where does this lead us? AWS decided that this was a great protocol, but it was hard to implement. Standard implementation requires you to write a lot of JavaScript code. It's not very flexible. When you have to write code, deployments are a problem. So we said we can do better than that. We can make this scalable. We can make this scale to millions of users. We can make it scale to multiple data sources. And we can do this and add real-time and offline as well. So we have all the capabilities there. How do you actually do it? Well, AWS AppSync is a console on the AWS system. And the way to create a protocol, create an AppSync API, is you first of all create and upload a schema. There's plenty of resources. If you want graphql.org/learn, will give you the requisite knowledge to create a schema. But in essence, you're creating types. The type is your security boundary. This is, as a back-end developer, you say, I want this data to be exposed to my clients. Okay? Not all the data maybe, but that's the set of data that you want to expose to your clients. And then it has a set of queries, mutations, and subscriptions. It says, this is the queries that I am allowing my clients to use. These are the changes that I am allowing the clients to do to the data. Okay? And each mutation, each query can have fine-grained access controls on it. You connect that to a data source. Right now, we support DynamoDB, which is a highly scalable NoSQL store. We support Elasticsearch, which allows you for faceted search. It allows you geolocated search, geofencing. And we support Lambdas. So AWS Lambda allows you to connect to any other data source that we don't support. So if you've got your data in RDS, if you've got data in some SQL database that's connected through a VPC, if you've got a HTTP service that you've already written that you want to leverage this technology with, then that's the way to do it. And finally, we have a client piece. So the client piece gives you that offline and real-time component. Building a GraphQL API, again, if we can switch back. I'm just going to log into my account here. Building a GraphQL API is easy. I can probably do it in about 3 or 4 minutes. Let's see. So first of all, if you want to find it, you can type AppSync, but you can also type GraphQL, and it will just come up. Now, in terms of regions, we've got currently, we've got Asia, we've got US, and we've got Europe covered. It's not available in the Mumbai region yet. However, we will be launching AppSync in the Mumbai region in the next month. So that's coming for you. I'm going to create an API. Let's go AWS Summit Mumbai. This is just a descriptive name. Now you can start with a sample, but I'm going to start completely from scratch. Just click on Create. Automatically, it will give you an API key. There are 3 authentication mechanisms: API keys, OpenID Connect, which is generally Amazon Cognito user pools, and IAM. So if you've got roles, you can integrate it that way. So the first thing you do is create a schema. A schema is fairly, hopefully I can see this. It starts with, I can actually just use this one. It starts with do a schema, has queries, has mutations, and that's it. We can get a query like this. There's my query, so it's just get a single post. I can do a mutation, which would be put post, and then I've got a type, and this is where people mostly start. So my post is just a title. That's fine. And I'm going to change these to X so that I don't conflict when I do the next bit, and you'll see why in a moment. And I'm going to click on Save. So most of my time when developing a schema is spent in defining what the clients actually need to do, and that is driven by the UI, and what data they need to return. Okay, and I'm going to think broadly. I'm going to say, given this data set, what do they actually need? What could they need in the future? And I'm going to write the schema like that, because that allows me to let the front-end developer just develop their app, and they don't have to come back, and I don't have to do a redeployment for additional things. It's all about the security boundary. Now, the next step is I want to put a database behind this, and I don't really know what I'm going to do. So I'm going to do create resources, and it's going to be based on the post. And it's going to actually create a whole bunch of resources. This is why I put the X in front of it, because I'm going to do a get post and a list post and a create post and update post, and it's going to do subscriptions. This is all created for me. So all I need to do is create the schema, click on create resources, and it will do it for me. If I don't care what sort of database is on the back end, I just want it to operate, I want it to be scalable, I want to store the data that I've defined in the schema, this is all I need to do. Okay, so it really is, what was that, minute and a half with the explanation. Some of the neat things that we can do here. We can attach what are known as resolvers. Now a resolver is, if I just go, where's my create? If I just look at these, some of these, the get post as a for example has a resolver, and what this does is it turns the GraphQL schema query with all the parameters that I passed in into something that my data source understands. So in this case, it's a DynamoDB. So I'm taking all that information, and I'm saying transition it to DynamoDB and give me the results back. So there's an inbound resolver, a request mapping, and there's a response mapping. Okay, it's written in Velocity, which is a templating language from the Java world. There's lots of utilities to help you change from GraphQL to DynamoDB, for example, GraphQL to Lambda, GraphQL to Elasticsearch. Now, some interesting things here. The first thing is, you don't need to use the same data source for all the queries and all the mutations. Okay? You could have mutations go to a DynamoDB table that then streams the data out and puts it into the Elasticsearch so that you've got efficient queries. And you're doing mutations against DynamoDB and queries against Elasticsearch. Okay? And you might want to do that, for example, if you're doing a geo app. So, for example, Yelp. Tell me all the restaurants within a mile of my location. Okay? That would be an example of a geofenced search that can't be done by DynamoDB. It can be done by Elasticsearch. So that's one of the reasons why you would do that. The resiliency of the data model in DynamoDB is great. The search capabilities in Elasticsearch are great as well. Okay? You can also combine data sources. So you can say, I've got a data set, for example, here's my customer, but the database for the actual customer information comes from maybe Salesforce. But the data for the products that they have purchased and their purchase history comes from RDS, comes from Aurora, something like that. Okay? So there's lots of options about how you can combine data. The facade that you present to your app is different from the representation of the data on the back end. And your clients don't need to know the difference. So that's creating an AppSync database. Can we switch back to the slides, please? So how do I actually use this technology? I'm going to assume at this point that you're developing some sort of UI-based application, a web application or a mobile app. We have SDKs for Android, so if you're writing in Java or Kotlin for an Android native app, for iOS in Swift and Objective-C, and with JavaScript, React Native for cross-platform mobile apps, React, Angular, Vue, Ember are all available to you, any JavaScript technology. All of those clients have integrated query caching and mutation capabilities. So that allows you to operate offline. You basically go and fetch the maximum amount of data that you need for your offline use case, and then we will cache that for as long as it's needed. Mutations will be queued up, and then when you go back online, you just have to trigger that kick to I'm online again, and it will filter the mutations to the back end in the order that they were submitted. Conflict resolution. When you are offline, conflicts are a big deal. Number one, make sure your IDs are strings and are globally unique IDs. If you don't, it doesn't work. Sorry. You can do conflict resolution in the cloud. 90% of the conflict resolution cases present a user with a form, and then the user goes, well, my data's okay, so I'll just accept that. Okay? If they're going to do that anyway, do it for them. Okay? You can still return a HTTP 409 or 412 that says there's a conflict, present the user with the information. Okay, and you get the server record back. You already have the client record. You can present both of them and say, which data do you want? Okay, and that's just a UI screen that you have to do. Real-time subscriptions are event-driven. We'll have more about that in a moment. Data sources. We support 3 today. You can easily combine different data sources into one API. You are not restricted with what we provide. You can write your own as well. You can also support relationships between data sources. So I've been using the movie database. You could have the movies and the actors inside of one database and then have a movie ticket system that uses another data source. And then you say, give me this movie with the actors and the available showtimes from a different system. Okay, and it will munge it all together and return one record to you that you can then pass on the client side from those 2 different data sources. Authentication is a big deal. Okay, we heard earlier GDPR. The compliance arena that allows you to be forgotten is gaining strength. You can't delete the records for a user if you don't know who that user is. It's just as simple as that. So authentication for your mobile apps, for your web apps, is going to become more important, not less important. Okay. Now, we've got 3 that we provide. The API key is what you use in development. Easy to get started. You embed it in your app. You're done. You can't tell which user is which. You do get the device ID. So you get the device of the system making the request, and the device will always have the same device ID. If you're a web application, we will create a globally unique ID, store it in a cookie, and that's the device ID that you get back. Okay. The next one up is Amazon Cognito user pools. You can actually use any OIDC compliant source for this. That gives you a user directory, it gives you group permissions. So you can place users in groups and you can say this query or this mutation is allowed by this group and this other one is allowed by this other group. Okay? And the final one, if you're using federated identities, so if you want Facebook authentication, for example, or Google authentication, and you want roles, and you want queries and mutations to have be attached to roles, then you can do that with IAM. And that's if you're thinking about capabilities from the available set, that would be Cognito identity pools or federated identities. Request and response mappings, velocity templates. We've got a whole bunch of templates that are just pre-programmed in that you can get a drop down and say this is a list, so I want a paged list response. The standard templates for those. This is also where you can implement fine-grained authorization controls. So if you can't fit it into a role or a group and you want to say this record is only available to this user if the user ID in the authorization header matches the user ID of the record, then you can do that with the search capabilities within the templates. Real-time data. Not every data source, in fact very few data sources have the requisite eventing structure to provide real-time data. Okay, DynamoDB has streams, which is great. Generic lambdas, not so much. Elasticsearch, definitely not. The mechanism by which we do real-time data says whenever we do a mutation through GraphQL, we'll do the mutation first, and if the mutation returns success, then anyone that is subscribed to that change will get a response back saying, here's the new record. Okay? That allows us to do real-time access to any data source, irrespective of that data source's position, irrespective of whether it supports real-time. Okay? And that scales to millions of users as well. So you can trigger any data source in AppSync with real-time capabilities, and that's just awesome. In terms of writing data-driven applications with AppSync, my very first AppSync app, which was way back when it first went beta, I said I'm going to use all the features. I'm going to write a chat app. I'm going to do lambdas. I'm going to do Elasticsearch and DynamoDB, queries, mutations. I'm going to everything. It didn't work the first time. It took me about 3 weeks to write it, and the way I did that was backing off all the changes and going like, okay, well, I'm just going to do GraphQL. I'm going to do queries and offline, and I'll just turn the flag on for offline. And I worked up from that point to say it works now. Now let me get the mutations working. Now let me get subscriptions working. You can add little bits along the way. Use the appropriate service for the task. This is a UI-driven application protocol. If you're not doing UI work, don't use it. Okay? There are other capabilities. If you're using S3, you're going to use REST. If you're going to use triggering random services that are a queued system, for example, that you're just triggering, use just a standard HTTP endpoint behind an API gateway. Okay? And finally, subscriptions. Subscriptions are expensive, and they're not expensive in terms of money that you have to pay. They're expensive in terms of the cost of the subscription to your user's mobile device. It takes battery and bandwidth. So if you've got a large payload, or you've got paginated data, or you've got things that change relatively infrequently, just use a query. Okay? Just use a query and offline support. If you've got something frequently changing, let's say you're doing a chat app. I've got a demo that I'm currently working on where I'm using comprehend and translate so that I write my text in English, and if someone is reading it in a different language, they get it automatically translated for them. It's using AppSync. Because it's a chat app, it's rapidly changing. That's where I use the subscription. Okay? And I've got 5 minutes left, but that is everything I need to do. I strongly recommend if you're building data-driven apps, don't worry about the back end. We've got a lot of tools in the mobile space to deal with it. AppSync is another tool in that toolkit. We also have API Gateway and Lambda. We have Amazon Cognito. We have Pinpoint for analytics. So we have all the tools such that you don't need to spend a lot of time on the back end. My typical back end for a mobile app, even when I have to think about the model, is generally less than half a day's worth of work to implement. Okay, and that's designing the schema and everything else. I spend all my time on the front end, and we have all the capabilities within that front end in terms of mobile SDKs for you, in terms of easy ways of accessing cloud data. If you're a JavaScript programmer, I strongly recommend you look at the AWS Amplify library. If you're a native developer, we've got the AWS mobile SDKs for Android and iOS. So please do take a look at those. And if you have any questions, just tweet at me. I'm AWS for mobile. That's me. I deal with the Twitter account. I'm happy to field questions. Thank you very much.